and welcome to episode 199 of our SAP on Azure video podcast. Today is June 27th, and together with Robert and Goran, we're here to talk about anything related to SAP and Microsoft. Hello, everyone. So a few weeks ago, we already talked about the importance of an high I/O and throughput when it comes to storage. Actually, from an Azure side, we have some really powerful storage options. Among them is Azure NetApp Files, a first-party integration of NetApp Files in Azure. This service has been around for quite some time, and we already talked about it in the past. Now, I'm really happy to have Geert back with us to share us the latest news on Azure NetApp Files. Welcome, Geert. Great to have you back on our show.
Yeah, hey, thanks, Holger, and it's good to see you after such a long time. And you know, you look radiant in this warm day and age that we're in. With the nice blue background that you have there, I think it really matches the temperatures that we're in. But hey everyone, I'm Geert van Teylingen. I'm product manager, one of the product managers for Azure NetApp Files in the larger strategic alliance between Microsoft and NetApp. I've been on the podcast before, and I'm really happy to be back to kind of go over the latest additions and all the nice things that we can talk about as far as SAP and databases and storage and and I/O and throughput and performance is concerned, data protection, you name it all. And it's funny that you say Azure NetApp Files has been around for a while. Actually, a couple of weeks ago we celebrated our 5th anniversary in GA. Yeah, so it's funny that you say that. So yeah, we've been around for a while, and I think we're still we're growing from an adoption standpoint and also from a workload coverage standpoint. I think there's a lot to share already from where we were last time around when I joined the podcast. And I think there's also an interesting roadmap that we have going forward. Now, obviously, we're not going to talk about roadmap stuff in this conversation, but I think if we do another update, so maybe 5-6 months ahead in time, then there's going to be a lot more interesting stuff to share. So we're even though we're 5 years old now, we're still developing, evolving, and it's all very nice to be here.
That's actually really cool. As you said, I mean, this is a product that has been around now for quite some time, but it's still getting new features, which is really, really cool. And although you were not on the podcast, we did talk about Azure NetApp Files actually in some other discussions, especially when we talked about customers running huge Oracle installations on Azure. Then there we see Azure NetApp Files being used very, very often. So yeah, I'm really looking forward to hearing some of the news that happened since you were last on the show. So maybe I know there's a nice webpage where you document all the new releases. So maybe you can give us an overview or a brief rundown on the new functionalities that have been released.
Yeah, let me pull it up right here, Holger, and I think you should be able to see this page now. When we're kind of pre-discussing, having this podcast, we were like, okay, how far back are we going to go, right? Because I think the last time I was on the call was probably October, November timeframe last year. I was like, maybe that's a little bit too far back. A lot of things have happened in the meantime. I think Ralph Klaar has been on your call also in the meantime, talking about, I think, ANF backup and all that kind of, important stuff. Because to your point, storage is challenging not only from a, performance and scalability and flexibility standpoint, but also from a data protection standpoint, right? Because especially as your data sets get bigger and your enterprise demands grow stronger, then the challenges become larger as well, right? Because backing up, let's say a 100 terabyte database is a different ball game than a 100 gigabyte database, right? So you can imagine that a lot of things that we're talking about with customers are around those areas, right? So it's about performance, it's about scale, it's about disaster recovery, it's about data protection, and I think there's a lot of good stuff to share, right? So if you look at the page right here, That's the Azure NetApp Files What's New landing page, if you will, and that's where we basically announce all of our new additions, big and small, right? Of course, we also communicate our larger updates through Azure Updates notifications, but even the smaller ones are also listed here, and I think it's important to kind of go through all of them. So I decided to kind of go back till March, and then let's go through the list all the way up till June to give you a little bit of a view of the last 3-4 months of the most important things. And of course, I'm going to cover specifically, I should say, point out the things that are important for SAP, right? So if you look at March, then the first line item there is not that interesting because it's large volumes, although it's a very powerful capability. It's not really meant for databases in such that you're going to benefit much from that. So I'm going to leave that out. But the next one is actually a lot more important, right? So as we've gone through our development and evolution of high availability deployments, etc., then we all realize that zonal deployments are of utmost importance, right? So not only the ability to land your virtual machines in a particular availability zone, you also need to be able to land your storage in the availability zone of choice, and preferably the same availability zone, so you can isolate failure domains, you can start building high available architectures across availability zones, etc. So that's where the availability zone volume placement feature that has been around for a while now has gone GA, right? And that means that, of course, that customers that want to rely on this high HA capability can now safely do that without any, let's say, preview challenges or anything. The good news is also that we have a sub option, if you will, or a sub feature that will allow you to what we call populate existing volumes with availability zone information, right? So imagine that you deployed a volume 3-4 years ago when availability zones weren't supported in Azure NetApp Files at all, but by now you want to kind of elevate or that volume to contain AZ information. You can now do that, right? So you can then say, hey, where is this volume actually located? Is it in the zone that I like? Then I can populate that information, and then going forward, I can start adding, cross-zone replication to that, to other zones, or I can build out my architecture in another zone to build HA as well, right? So that's a powerful feature to basically evolve your already existing deployment, and preferably without needing any data migrations, right? So that's a very interesting capability. That little sub feature is still in preview, at least in the March timeframe, but we're looking at evolving that to GA as soon as well. Okay. Now, what's also interesting is that if you look at the capacity pool announcement, obviously everybody that's aware of Azure NetApp Files realized that in the early days we started out with 4 terabytes minimum capacity pools, right? And that is great if you have sufficient data for your deployments or use cases that need more than 4 terabytes, then all good. But if you have a scenario where I need to start smaller, for instance, I have a test or sandbox environment that doesn't need much, and I still want to have that deployed in an isolated environment, then I don't need that 4 terabyte. And if I need to deploy 4 terabyte just for that, then I'm overpaying, right? So we've lowered our limits from 4 to 2 initially, and now to 1 terabyte as well, which basically means that you can cut out a lot of the waste for these smaller type deployments, right? So I think that is interesting for environments that are, let's say, large and small, where you cannot necessarily combine your deployments on a single large capacity pool, and you want to kind of isolate it, right? So that's kind of an interesting one as well. And then the last one, if you look at that volume enhancement, it's actually a mouthful if you look at it, but it's basically the ability to create volumes with the same name and the same share name in the same region, but in 2 different availability zones. And that is a particularly interesting if you want to build an HA setup and you want to be able to fail over your volume and you need to do a remount, but you need to have the same export file name or export directory, right? We couldn't do that before, and basically you had to kind of make all kinds of complicated scripting to remount your volumes in a different folder name and all that complication. That's all gone, right? So we've done a lot of that improvement in the in the manageability space as well, especially for let's say transport, shared files, kind of scenarios where you want to replicate between zones.
Mm-hmm.
So that's kind of in March. And if you go to April, I think this is a way bigger one, right? So if you look at, SAP deployments, then obviously you can talk about SAP HANA, which is something that we've been big on for a very long time. But as we expand let's say our view of, let's say deployments and database supportability, then Oracle is of course the next one that comes up in the, in the SAP NADB space. Also, of course, in vanilla Oracle environments, right? But especially in the SAP space, we do come across a lot of those, how would I say, long-standing deployments that are not migrated to HANA or anything, and they still need to be maintained, or they need to be migrated to Azure, and Oracle is the database of choice. And then, we do come across, how would I put this, significantly sized environments, right? And significantly sized means multiple tens of terabytes, if not over 100 terabytes in size, from a single database point of view. And also environments that, for instance, on-premises run on Exadata that require, let's say literally gigabytes of throughput, right? And if you land into environments where you need, not 4 or 5 gigabytes per second read or write, but up to 8 or 9 or even higher, then you're going to be fairly challenged in getting that going, right? And because the reason for that is that if you pick any virtual machine, then any virtual machine is limited in terms of throughput. Especially on the disk side, there is limitations that you have to deal with, right? So at that point, you benefit from using network storage over disk storage, because network storage uses the network interface, which gives you a lot more bandwidth on any given virtual machine, right? So that means that you can really get a lot more throughput out of virtual machines and drive higher throughput workloads in Azure using network storage like Azure NetApp Files. Now the challenge that becomes is, okay, but what if my database is more than 100 terabytes in size? Then obviously, you already run into a volume size limitation, because an Azure NetApp Files standard volume or regular volume cannot grow beyond 100 terabytes, right? So let's say you have a 140 terabytes database, which we have customers running, then you obviously need more than one volume to start with, right? And then in other scenarios where I say, hey, wait, I don't need maybe 1 gigabytes per second throughput, but I need, 3 or 4, 5, 6, or even 7. In some cases, actually, we're running, and I'm going to show you a benchmark later, 10 gigabytes per second throughput or more. Then I'm going to be challenged, because any regular ANF volume is limited in numbers of reads and writes around 4.5 gigabytes per second maximum sequential, or 1 for reads and 1.5 gigabytes per second sequential for writes, which means effectively you need to be able to run or spread that workload across multiple volumes, right? Now, interestingly enough, if you're a little bit familiar, and it gets a little technical, but it's important to know, the moment you start deploying your data and log volumes on a single virtual machine, and you mount those volumes on the same network interface or the same storage endpoint, effectively the same IP address, then the Linux NFS client prioritizes writes over reads, which means that if you have a write-heavy workload, your writes are going to choke the reads on the same interface, right? So that means effectively you need volumes that are not only independent, but they're also independently connected to an independent storage endpoint, because that will eliminate that choke point, right? So now in all of that, in order to deploy such a thing on Azure NetApp Files, you need a little bit more than just click a volume and you're going, because you don't have control over your storage endpoint. And that's where application volume group for Oracle comes in, because that will give you that deployment to make that happen end to end, right? So I'm going to talk a little bit more later about, okay, so what does it look like? So what does it really architecturally look like, and what does it give me? Got some diagrams to show, and also what does it give me performance rights, right? So I think it's a major improvement for any size Oracle deployment that we can land. And basically, the short, I would say, summary is, the moment Azure brings virtual machines with higher network throughput, the higher workload we can handle, because ANF basically scales horizontally, and there's fairly no limit in that regard at that point, right? So to kind of give you that idea. Then if you go back to May, I think there's a few important ones as well here. Actually, the important one is the one is mentioned here, and maybe I don't recall if it was covered with Relle the other day, with Ralph Klaar, but Azure NetApp Files backup is now generally available, right? It's been in preview for quite a while. There's been a few reasons why it took a little longer to let's say to graduate that from preview to GA. But now that it's GA, it obviously means that customers can start using this safely in any production-like environment. And I think Relle covered it the other day, but the short summary of the benefits of Azure NetApp Files backup, of course, is that the backup goes, the data transfers for the backup go at the storage level. So there's no host-based data transfers for any of your backup traffic. And it's block level incremental forever, which means that once you've done your first baseline, every subsequent increment is at the block level delta, which is typically a whole lot lower than your file level incremental, of course. And you especially see that difference in a big difference, for instance, between HANA and Oracle type databases, because HANA is, of course, since it's the way it's structured, is a little bit more delta or change heavy. So you'll see a change rate of a daily, anywhere like 20% or so, maybe sometimes even more. But with Oracle databases, you typically see anywhere between 1 and 5% on a daily basis at the block level, right? Which means that your daily increments are only 5%, and you still get a full backup every time as a result, right? So I think Azure NetApp Files backup in that sense is a major, business benefit game changer from a data protection standpoint. And again, think about it: if you have a 140 terabyte database, which some customers run, and you're running a file-based backup every week because you have to, versus doing a 5% every day. Yeah, I mean it's self-evident, right? I mean it's 7 terabytes daily versus 140 terabytes weekly, as a rough idea here. So nice. And then the last one I think I wanted to cover real quick is, of course, a little bit back to the SAP HANA world. Of course, Application Volume Group was released to market to support SAP HANA first. So that's been around for a while. And we recently, this week, actually released a extension to that to now support the previously gone GA of Application Volume Group, Availability Zone volume placement, which means that we're eliminating the need to do any AV set pinning, right? So now that you have your virtual machines in availability zone, you can basically pick the same availability zone for your HANA volume deployment with AVG, and it will be deployed in within the same zone and within the same low zonal latency envelope, right? So that gives you that low latency performance, and it also gives you that failure domain protection without all the cumbersome pinning that used to be required, and also without the need for PPGs. We don't need PPGs anymore in that regard. And we also support standard network features, which is, of course, has been a big ask from customers, because we are transitioning basically and defaulting to standard network features from the earlier basic network feature deployment. So yeah, I mean, it's been a little bit of a blast, I think, but I think it was important to give you guys a little bit of a highlights in terms of what we've done the last few months.
No, fantastic. And I mean, you even skipped a few things, so quite a few things have happened since then. Really cool.
I mean, as you know, Azure NetApp Files is aimed to cover a variety of workloads, right? Enterprise workloads ranging from, as mentioned, SAP and anything to do with SAP, databases, Oracle, but also other workloads like, support for AVS with AVS data stores or NF data stores for AVS, HPC environments, right? So there's a breadth of application workloads that we cover. So I kind of skipped most of the features that are in the other areas for this purpose. Yeah.
No, perfect. Then let's continue. Let's drill down in some of the topics.
Yeah. Yeah, so if you're gonna, let's say, focus a little bit on, let's say, the Oracle side of the world for now, right? I mean, obviously, I think Microsoft has made a big strategic move last year, with the strategic agreement with Oracle, now offering a whole lot more, solutions that involve Oracle, and that's where ANF, of course, plays a big role already, especially in the IS, deployment option, right? I mean, obviously, there's various ways in which you can now deploy Oracle databases in Azure. Azure NetApp plays various roles in all the various offerings in the portfolio, but I think the most predominant one is the IS type deployments, where you basically run Oracle on your virtual machines, right? And as mentioned, if you want to deploy an Oracle database that requires certain amounts of capacity and certain amounts of throughput, and you want to have that consistent without any choke points, then you need to deploy your volumes in a what we call a best practice fashion from a storage standpoint, right? And then, I mean, anyone familiar with how Azure NetApp Files is built? It's built, of course, on this bare metal fleet of NetApp systems, right? Those are hosted in Azure data centers, directly plugged into the network. So you basically get the highest throughputs that you can think of and the lowest possible latencies for as long as your virtual machines and storage are in the same availability zone, right? So, and that means that in order to let's say handle these type of deployments, you need to deploy in best practice fashion. And that means you need to deploy, if you need multiple volumes, you need to deploy them in the best way across the bare metal fleet that we have. You need to have them isolated from one another, and preferably you want to have isolated storage endpoints. So what we've done with Application Volume Group for Oracle, and here's the article that kind of explains the concepts, is basically give you how would I say, either a one-click or a wizard-based approach to deploy an Oracle environment of your choice, right? And then the end result is, of course, it comes with a layout, right? And there's a few layout options. And let's say the simplest way of thinking about a deployment like this would be, I've got an HA setup. I use DataGuard to provide my HA across those zones to provide my availability. And I need to deploy my virtual machines in the one zone, the other virtual machine in the other zone, and I need my storage volumes, right? And in this scenario, my sizing kind of dictates, and I'm going to come back to sizing, but my sizing dictates I need 2 data volumes. I need a log volume, especially in an SAP Oracle context. I need a mirror log volume because that's a prerequisite from SAP. I got some binary volumes, and I may have to have a backup volume because maybe not only I want to do snapshot-based backup, but I also want to occasionally run an RMAT backup for certain reasons, right? So this is kind of the default deployment. And this is what Application Volume Group can do for you. Not only can it create the volumes of the size and with the throughputs that you need based on the capacity pool service level, but it also will create, in this scenario, 5 separate storage endpoints, basically 5 IP addresses that you can mount your volumes on. So your log and your data volumes are isolated from one another, and only the volumes that can be sharing a storage endpoint will share a storage endpoint, right? So for instance, your binary volume, it doesn't matter if it shares the same storage endpoint as your backup volume, right? For as long as your log volumes and your data volumes are separated from one another, right? So this is kind of the simplest deployment that you can think of. Now, if you look at the full-scale deployment, you need to realize that Azure NetApp Files Application Volume Group for Oracle now supports up to 8 data volumes, right? So think about that, up to 8 data volumes. Each data volume potentially being up to 100 terabytes in size means effectively that you could theoretically host an 800 terabyte database on this deployment, right? So from a size perspective. Now, if you were to take the highest available throughput service level, you could run an 8 times, roughly, let's say 4 gigabytes per second read on this, which is effectively, what is the math? 4 times 8, 32 gigabytes per second throughput, right? Now, the truth of the matter is, of course, there's no virtual machine today available that pushes that kind of throughputs. But if you spread out the workloads across multiple virtual machines, you can actually do that, right? So
Yeah.
we have cases where, and I'll show you the benchmark, where we've done multi-host environments that pushes up to 30 gigabytes per second throughput across a large landscape of volumes, right? So this is what a, let's say, full-scale deployment looks like. Now, this kind of implies that there's a lot of Azure NetApp Files resources available in the region or in the zone that you want to deploy this in, and that's probably the case in in most of the regions, right? But there might be regions where these are not very let's say highly deployed or highly utilized regions, and therefore of course the resources might be available resources might be somewhat limited. In that case, what we do is we optimize in a different way, and that's where we say we can, even though we want to separate log and data volumes from one another on the same storage endpoint, we can still share the same storage endpoint for data volumes, right? So in that case, the deployment logic will say, hey, in this scenario, I'm limited in resources in the region, but I can still handle your workload by just sharing or deploying multiple data volumes on the same storage endpoint, and then you would end up with less storage endpoint, but you'd still get the performance characteristics that you need, right? So what we try to do is optimize as much as possible, and then give you exactly what you need. And conceptually, this is what Application Volume Group does. I can show you the GUI later on if you want to kind of show you in the portal a little bit what that looks like. But this is what effectively does. And this article describes it in very good detail.
Perfect. Cool.
So yeah, and then of course you may wonder, okay, so now all nice and good, but what does it mean, right? So what does it give me, right, as a customer, right? And that's where we've done some benchmarking, and we've done some benchmarking with multiple volumes based on actual customer scenarios. So there's a customer that came to us and said, hey, we have a data warehouse type workload. It was a retail company, and we need 15 gigabytes per second throughput on our database. And then we said, that's interesting, because 15 gigabytes per second throughput, that means that if that's all read, there is no virtual machine in Azure that can actually do that. So how are we going to solve that problem? And they say, wait, actually it's 50% read write. So it's like 8 gigabytes per second read and 8 gigabytes per second write. Okay, that helps, because what you also need to know is that, of course, your network interfaces on virtual machines are duplex, right? So it can do reads and writes, at the same time, up to the network connectivity speed, which is typically 100 gigabits per second throughput that you get on, let's say, the most typical virtual machines, right? And that's without Azure Boost, right? So Azure Boost is another topic altogether. We could talk about that. But fundamentally, this is what the problem statement was, right? And then they said, not only do we have that, we also have a scale-out need where the total of three, if we run this across 3 virtual machines, we would need about 30 gigabytes per second through the total for our entire application landscape. So that's an interesting challenge, and that's exactly why why we built Application Volume Group for Oracle, right? Because what you need, and that's what we've done here, we've demonstrated this. What you need is that type of scale-out scenario. And what we've done first is we've done single host storage I/O throughput based on on the workload that was provided to the customer by the customer to us, which was in this case predominantly sequential. Now, I mean, anyone in the storage world knows that sequential I/O is a little easier to handle than random I/O, because randomness, of course, increases latency profiles quite a bit. So now this was a predominantly sequential throughput or sequential workload, and with the single I/O throughput, let's say benchmark, we demonstrated about 800,000 random read I/O per second, right? At a latency of, and I need to look at it, when it was 800,000 of a latency at less than 600 milliseconds. So 600 microseconds, I should say, 0.6 milliseconds, right? Which is quite fundamental. Absolutely, because obviously latency is king in this kind of environment, right? So that's one. And then if you look at throughput, then of course, the moment you increase your threads, then you drive more workload, right? You drive more work. And the moment we increased the threads to about 4, we were able to basically max out the network interface, right? So we were about 11 gigabytes per second throughput in this type of scenario, which was for pure reads, which was way beyond what the customer needed, right? But they needed kind of 8 gigabytes for reads, a rough 6 gigabytes for writes. So that gives you that, right? And then of course we can also scale this out, right? So I showed you the diagram here, right? So we go back here, we show this diagram, that's a single host deployment. You can also do a triple host deployment, right? So that's where we scale this out. And we basically use 3 application volume group for Oracle to deploy this type of work, right? So we ended up basically requiring 5 data volumes per host. And they use redo volumes and an archive volume as well because of some internal requirements. But this is what they needed, and that basically 3 times. And that's where we deployed this on the same availability zone. And by sharing some of the stored endpoints, we could manage this type of deployment, right? And then we did the same test, right? So 2.5 million IOs at, let me see, 0.6 milliseconds, right? And throughput-wise, we demonstrated the collective of a little bit north of 32 gigabytes per second throughput for the 3 hosts combined with 4 slot threads, right?
Nice.
So basically that's what it is now. Now we also looked at the benchmark and say, okay, now this is a fairly specific, I would say, workload, which is not super common. So let's try to look at a little bit more real world where, there's a little bit more randomness to the workload as well. And the block sizes are a little bit different. And basically, this is what we've shown for a single volume throughput, what we can read. And then if you combine those, of course, then you can drive this type of workload. Now, one thing to note, Holger, is I think we may have talked about it before, but I think it's important to realize that we're using direct NFS for this, right? So direct NFS, and we have articles about that as well. I can actually show you live. Oh, there's an article here that compares direct NFS with kernel NFS, right? And kernel NFS gives you about 1/4 at most of the throughput that direct NFS can give you, at latencies that are way beyond acceptable. Right, so if you look at the direct NFS graph here, of course, it pushes a lot more I/O than a kernel NFS could ever do. And that's because kernel NFS is in principle single-threaded, and direct NFS is by design multi-threaded. Right, so you get multiple connections driving multiple I/Os across the same wire, and it kind of gives you this type of capability. So on a per volume basis, you get a lot more throughput through direct NFS. And then in this article, what we also call out is, sorry, I should go back to the article here. In this article is that, hey, if you want to, let's say, if you have multiple data volumes and you want to spread the workload across all these data volumes evenly, then we recommend using ASM. So Oracle ASM is then the means to basically create a what's called a disk group. Right, that would then combine all these volumes to a single virtual disk, if you will, and then spread the workload evenly across that. So that also avoids any potential hotspots on a per data point of view. And this is all described in this article, right, including the tests that we've done, the tools, the tunables that we've used to kind of give you all that information. Also, anything that had to do with the virtual machine involved, and some tunables that you should be doing there as well. So I think it's quite comprehensive in terms of, this is what the outcome is effectively.
Yeah. So if you really want to have super high throughput, then this is the way to go.
Yes, this is absolutely the way to go. So application volume group is absolutely the way to go. Now, does that imply that Azure NetApp Files is only suitable for large or extremely large databases? And the answer is, of course, is no. It is also suitable for smaller databases, and especially if you have landscapes that have a lot of sandboxes and test QA environments and whatnot that are tiny, then it is those are typically, they typically demand a lot of resources on the CPU or the memory side, right? So ultimately what you'd like to do is combine those databases or landscapes on singular virtual machines as much as possible, right? Because that will save you on cost. But if you still want to have some sort of independent data protection, you do want to be able to separate your data out of that, right? So now if you have a disk, you can only attach so many disks to a virtual machine, right? So if you say you have an environment where I may have the need for up to 60 or so very small virtual machines, and I can land it on an E96 or something, versus having to have 4 of them, then why not? But you need to then have a means to create your independent data volumes. And hey, that's what ANF with NFS can do, because you can create as many mounts as you want, and you're not going to be limited, right? So even consolidating a lot of this small grain stuff is a very easy to do, and that saves you ultimately a lot of money. So that doesn't necessarily require application volume group for Oracle, right? Because then those volumes are simple, straightforward. You can just deploy them as you want. Now I can show you, Holger, if you want, a little bit what it looks like.
Yeah, absolutely.
So let me go. I'll skip a few tabs here because I'm gonna come back to the topic of sizing. But let me skip through this tab, right? So if I go to my Azure NetApp Files control plane, I already clicked there and I selected my West US2 region just for now. And if I go to my menu branch here under storage service, I see application volume group, right? So I can select that. And you can also see that I don't have any group available today, right? So I already clicked in preparation, already clicked add group. And what you get is basically a wizard, right? A couple of tabs that you have to go through from left to right. I already picked, and I can show you a little bit better if I close this and I say add group again. And I can pick my database type, right? So in this case, I can either pick HANA or Oracle. Now in this case, I pick Oracle and I get to this control plane blade, right? And then I can enter, I need to enter a few fundamental points of information, right? So of course I need to have a unique system ID, because I may be deploying 15 of them, right? So let's say my unique system ID for this one is Aura1, right? It will give me a group name that includes the system ID name for reference, and it gives a description, right? So this could be for Holger's podcast, right? So for this just a reference.
Yeah.
And then I can see now, based on sizing, and again, I can come back to sizing later. Based on sizing, I need 4 data volumes, right? I know that my database in size is, well, pick a size, Holger.
Let's how many terabytes do we have? Let's start with 2 terabytes.
I'm going to tell you, I'm not going to deploy it because it's going to take a while, but I'm going to show you the wizard. So, but effectively, I could say, hey, 140 terabytes, right? Think about it, right? I got 4 volumes. Okay. Each volume could be up to 100 terabyte in size. So in this case, I would be easily able to handle that. So what I'll get eventually is 140 terabytes divided by 4 equals the size of the volumes, right? That's kind of what it gets. Now what I can do is I can include or keep additional capacity for snapshots in mind, right? So maybe I want my database size is 140. But I would say, hey, I want to keep snapshot and I expect 20% of extra capacity for that. And it will add that to the 140 here. And here I basically can enter the throughput that I need, right? So let's just say I need 6 gigabytes per second throughput. And then I go to the next volume group, right? And it's going to ask me a couple of things. So which availability zone do I want?
Yeah.
Now, obviously that can be 1, 2, or 3, or none, right? You can also say none if you don't want to, but normally we would not recommend doing that, right? Because if you are in an availability zone enabled region and you do not pick an availability zone, then your data could land anywhere outside of the zone of your VM, right? So we say, hey, make sure that you match this with the zone of your VM here. That should be the same zone, right?
Yeah, absolutely.
Yeah. Now, application volume group for Oracle already supported standard network features from the get-go, right? So what we've just recently added to AVG for HANA, it was already available from the get-go in this one. And now I realize that I have to pick a capacity pool, which I did not create up front. So let me go back to do that real quick. Let me see. The easiest way to do that would be to open a new tab. I'll go to my portal. I missed the preparation step in that one. So you may want to...
good. Now we see how to create the capacity pool. That's also good.
Yeah. If it comes up. Go to my Azure NetApp Files. I go to my NetApp account in West US2 that we had, right? And I go to Azure Files, capacity pools here, of course. I'm going to add a capacity pool. And it shows here that there is a capacity pool available, right? So you may wonder, why is this not showing then as a selectable option, right? And the reason for that is that the capacity pool for application volume group for Oracle requires manual QoS capacity pool type. And the reason for that, of course, is that we want to be able to independently set the size and the throughput of those volumes based on the needs that we have. Right? So instead of auto QoS, where you have this linearity between capacity and throughput, we need a manual QoS capacity pool. So let's say we say Aura pool. We just pick premium for now, doesn't matter. And well, of course, I should say 140 terabyte, at least in this case. I'm just going to say, I'm just going to say deploy 4 for now, just to show you what manual. And I pick manual and I say create, right? So now that takes about a couple of seconds. And then I have a capacity pool available to me.
Perfect.
Now,
so
I go back. Unfortunately, I do have to restart my my sequence here. So let me go back to that again. So I'm going to add an application volume group. I'm going to say Oracle again. I'm going to say Aura 1. Well, I'm going to leave the description out here. Or sorry, I'm going to group name is the same. I'm going to leave the description out. I said 4 volumes, 140 terabytes, 20%, and 6 gigabytes of second throughput, right? And then I go to my volume group. And I pick availability zone. I pick the zone that I want, standard effort features, and here I can choose my pool.
Okay.
Right.
Now it shows up, yeah.
And then I have to pick my virtual network and my dedicated subnet, right? So this is where my volumes will then ultimately deploy. Now these were prepped, but normally you would probably have your own dedicated virtual network for your database. Then we go to tags. I mean, I can add regular tags to this, of course, normal. Then I can pick protocol, right? So we support NFS 4.1 and NFS v3 with this. Typically, I would recommend, if you don't need anything specific for NFS version 4.1, I would recommend using version 3 because that is a little bit more performant. So its performance is more of importance than V1 or than anything like security, for instance. Then I would say default to version 3. And then I can go to my volumes, right? And here I have the option to alter my default, right? This is my default design that I get. Obviously, I picked 4 data volumes, so I get 4 data volumes. But you see there's an asterisk here in front, these volumes, because these volumes are optional and can be removed, right? So if I say, I'm not very interested in a log volume, mirror log volume, I can delete that from my volume group before I deploy. Or I may not need a backup, or I'm going to store my binary somewhere else. I can leave those out, right? For now, I'm going to leave them as is, and then we go to create. And then normally, as it goes to deployment, and it doesn't have enough capacity, right? So it will not allow me to do so. But it would then deploy those volumes for me. And that's kind of the wizard. Obviously, there's an API, CLI as well, right? So you can also do that in an automated fashion with all kinds of pre-entered information.
Nice. That looks fairly easy, just to navigate through.
Yeah. And then one thing that you said, you may want to say, okay, now that's all nice, but how do I know if I need ultra or premium for my workload, right? So what is the best way to deploy? What is the best option or the best service level to deploy this type of volumes or this type of database, right? Then it kind of comes down to sizing, right? And sizing is something that we created let's say in the public domain, there's a tool that is available to do Oracle landscape assessments and also to do ANF based sizings for you, right? So I'm not sure if you're familiar or your audience is very familiar with this initiative, atroposs.
I'm actually not. Yeah.
If not, I can highly recommend looking at it, because it gives you an early, let's say, an early pre-sales like assessment of various parts of the a landscape. So it can give you a good indication as to where I'm gonna land with my setup, and it supports multiple things, right? It's not only limited to Oracle. It's not only limited to your virtual machine sizing. It also does storage sizing, right? So, I mean, if I go to start assessments, I get all kinds of modules available to me. I would highly recommend studying this a little bit. For instance, it's got an interesting AWR assessment capability, where you basically in this AWR module you upload your AWR reports, and it will do an assessment of that, right? And then that assessment can be outputted, and that output can then in turn, for instance, be used in your ANF module, right? So that information that is available in AWR does also show all kinds of throughput needs for your running database, which the ANF module can then use for actual sizing, right? Just to kind of give you the kind of capability. Now, I must say I'm not the expert on everything in this environment. I'd highly recommend getting in touch with the folks that created this. But what I can talk about, of course, is the ANF module, right? And what I did in preparation of this is I kind of prepped two sizings, if you will, for two different database types. And the first database I want to look at is a real-world customer scenario where the customer said, I have a database that's about 16 terabytes in size, so it's not huge, but I need about 8 gigabytes of throughput for that database, right? And I have some performance needs as well that are added to that, right? So what I've done here is I've entered manually this information in this input field, right? I'm going to close this real quick to not spoil too much of the information, right? But it basically said, the database says 16 terabyte size. It's got a fairly random I/O pattern to it, right? So you can choose if it's like random, if it's like sequential predominantly, or if it's a mix, right? So you have kind of three kind of workload buckets that you can choose. And each will have a different outcome, right? So depending on that, the sizing will be different. But in this case, it was a highly random workload, and I required 8 gigabytes of read and 2 gigabytes of write.
Yeah.
Right? So that was the requirement. I assumed a 1 terabyte log volume need, and I assumed, which is fairly accurate, 100 megabytes per second log throughput requirement. Right? And in this case, there was no need for mirror but you can add that. It will just add capacity needs for that. And I assumed a 7-day retention on the archive log, right? So for kind of data recovery purposes. So I clicked edit system, and then it shows up here, right? So that's kind of what it is. I can change anything if I wanted to that I need if I made some mistake or something. And then that will do, I can add multiple databases to this if I want, right? So if I have multiple databases in my landscape, I can add all of them. And then ultimately it will do a calculation in terms of what size of capacity pool do I need and what type do I need to host all those databases, and it will find the optimum, right? Now for this single database calculation, it created the output here. And what you'll see is that in this case, the pool size performance requirement is 510 terabytes in size, right? So that's what we needed for performance in the case that you're in standard, right? So for standard, you need 510 terabytes in size, which is quite big for a 16 terabyte database, right? For performance and capacity combined, we needed 510 terabytes, and then obviously the price is not optimal, right? Now, if you look at premium and ultra, and if I skip all the way to ultra, then for performance reasons, we needed 64 terabytes of capacity as well as for performance, right? So which means that in this case, ultra is the most cost-effective option. Even though you need a little bit more for this single database, but again, typically customers have multiple databases and they'll combine it on the same capacity pool, right? So, but this is basically to demonstrate, hey, in this scenario, small database, high throughput, I'm going to land at ultra, right? Now, does that mean that everything will have to land at ultra? And then the answer, of course, is no. So let's look at the other example that I talked about earlier. There's a customer that has a 140 terabyte database in size. and they needed different requirements from a throughput perspective. And I've entered that information here as well, right? So this example gives you 140 terabyte in size. It also was a random I/O pattern. The read requirement was a little bit less, 5 gigabytes per second throughput with 1 gigabyte per second throughput write. A little bit less for log, but the rest was pretty much the same, right? So I've added that to the sizer, and then the calculation shows a different picture, right? All of a sudden you see,
nice, yeah.
Hey, wait a second.
Yeah.
I may need a lot less capacity.
Yeah.
For performance or capacity and performance for Ultra, right? In order to fulfill the performance need, I only need 41 terabytes for Ultra. Yeah. But for capacity purposes, of course, because we have 140 terabytes
140 terabytes now.
I need at snapshot, I need 173. The cost is 70K. However, if I default to standard, then it turns out that I may need a lot more, I may use a lot more capacity because I need it, but my cost is still lower.
Yeah.
Because I only need 322 terabytes versus the 173 here, but the total cost is lower. And then that excess capacity can be used for anything, right? I mean, there's a lot of customers that use that for backup data. I mean, it's just still capacity that you can use for anything. And still you're off a lot more cost effective than defaulting everything to Ultra, right? So now, these are two kind of random examples. And again, these are single database calculations, which are always, let's say, a little bit suboptimal, because again, if you have multiple databases and combine them, and then obviously you get a way more effective use of your capacity pool as well.
No, but that's really cool, and that's very insightful. Because I mean, by default, you would think Ultra is just I mean, it's the most expensive one. You only need it for very high. But it's interesting to see, depending on what are actually your requirements, standard can be much better. Yes. Or even though if you have a small size, but you have very high throughput requirements, then Ultra might be more interesting. So that's actually a nice tool that helps you guide and select the right configuration. Yes.
Now, there's some development work going on to get this integrated into more tooling, more sizing tooling as well. In the future, you're probably going to see more of this. But this is already a very good step forward, because this at least gives the customer and the partner, or any CSA for that matter, a better way of giving an assessment where you don't overprice from the get-go.
Absolutely.
Because, if you like I said, I mean, if your assumption would be, I need Ultra, then you're going to pay basically 1.5 too much for your storage, which you don't need to, which could outprice your entire project, right? And that's obviously what we want to avoid with this approach.
Oh, really nice. Really cool.
Yeah. So
perfect.
I think, I mean, I've spoken a lot, of course.
No, that's good. That's good. And you showed us some really, really interesting things that I think is really relevant for a lot of SAP customers that run their SAP HANA or their Oracle workload on ANF. So, and with these optimizations, it's also really cool to see how they can get to the right configuration.
Yes.
So thanks for that.
Yeah, absolutely. And also, of course, we're more than happy to assist anyone in the field that may need some help here. We also created some good, let's say, visual, right? So there's a channel that we have. I can share the link to the Azure NetApp Files YouTube channel to include in your podcast notes. But that has a few playlists. One is a playlist called Quick Bites, and another playlist is called How To. Well, obviously, they self-explanatory, right? So the Quick Bites are like really short, 5-6 minute blurbs about any given topic that gives you the highlights of the topic, right? So in this case, there's a video called about application volume group for Oracle, which shows you a really condensed way of what it does. And then there's a how-to version as well that goes into the depth, right? So it talks about all the details and there's many topics. So
fantastic.
Also wanted to call that one out.
No, absolutely. I'll definitely put a link in there as well in our description.
Yeah. So
thank you so much.
What else?
No, I think that was perfect. That was very comprehensive. Really good. Thank you so much for this great update. I think we are up to date again with this. I'm sure we'll have you again on the show to give us the latest, as you alluded to. So when we were looking at the what's news section. There's obviously a lot of new things that are coming as well. So I'm looking
Yeah.
forward to inviting you again.
Yeah, make sure to bookmark the what's new, and yeah, let's also. I mean, we're going to be present in a variety of events going forward, like Microsoft Ignite, you know, NetApp Insight, those kind of events. So also, anyone interested in you know, in live conversations, feel free to join those events, and I think there's a lot more to come in the future.
Perfect. Well, Geert, thank you so much for joining, and we'll talk again. Thank you.
Thanks for having me, Olga. It's been a pleasure as always. I'm gonna hold you up to that tour. So let's see when we get to meet.
We'll do that. Yeah. Thank you so much, Geert.
All
Okay.
right.
Bye bye.
Ciao, ciao. Bye bye.